Hello, everyone. Welcome to this presentation. I'm really excited to be here, and it's great to see so many of you have decided to spend the next 20 minutes with me to learn more about what can a software engineer do about climate change. So what we are going to cover today, firstly, we will learn the principles of green software engineering. Next, I will share my journey so far as a green software engineer, demonstrating that software engineers can help accelerate the climate actions. Then we will go over resources that I have organized for front-end and back-end engineers, respectively. Hopefully, those resources can be a nice kickstart to your strategies to join the fight against climate change. I have set aside the last 5 minutes of this presentation for Q&A, so please save all your questions towards the end, where you can use the chat function provided by Hopping to type in your questions. Thanks, Iona, for a lovely introduction, but let me just quickly introduce myself again. A little bit about myself. My name is Sarah Su. I'm a site reliability engineer with Goldman Sachs, specializing in Amazon Web Services, and currently I'm supporting our consumer car businesses. I'm also a volunteer with Climate Action Tech. Climate Action Tech is a very vibrant online community for any tech workers who are passionate about climate change. If you have any additional questions after the session, please do reach out to me directly using my email, or you can connect with me on LinkedIn. Normally, when you read about climate change in the news, you see forest fire, you see drought, you see polar bears standing over ever-decreasing melting ice cap. All these events are very scary, and they are a great reminder for us all on how desperate the situation is. But they all seem very far from what we do day to day as software engineers. Guess that brings us to why we are here today. What exactly can a software engineer do about climate change? Let me quickly set the theme on how the software is actually heating the world. This is actually a really interesting series of blog posts called Developers Can Save the Planet. I do encourage you to check out the whole thing, but long story short, in the first part, the author estimated that a typical French person would emit about 14.5 kilograms of carbon per day. And 580 grams of those emissions come from digital activity. And about 55% of the digital emissions come from software. With almost everything requires a software, from pregnancy tests to self-driving cars, software is not just helping the world progress, it's also heating the world. So what we do day to day as software engineer can have a real impact on a global effort to decarbonize if we can adapt to build softwares that are sustainable. But what do we mean by building sustainable software? Up till recently, there is no industry-wide agreed definition on what GSE should entail. A lot of research has been done in the space, but people started to notice everyone has slight different definitions when it comes to calling something green in a software engineering context. So last year, a group of people from the Mozilla Foundation and Microsoft, they came together and gave GSE the following definition. Green software engineering is an emerging discipline at the intersection of climate science, software practices and architecture, electricity markets, hardware, and data center design. The first principle of GSE is all about carbon and how building carbon-efficient applications can have a real impact. Carbon is a shortened way to describe all greenhouse gases. Greenhouse gases are gases in Earth's atmosphere that trap heat. They let the sunlight pass through the atmosphere, but they prevent the heat that the sunlight brings from leaving. So essentially, greenhouse gases act as a blanket, increasing the temperature on the surface of the Earth. Do remember that this is a natural phenomenon, but due to the crazy amount of human-made carbon pollution, the global climate is changing at a rate that is too fast for us human, animals, or plants to adapt. So the goal of the Paris Climate Agreement is to reduce carbon pollution, so the temperature increase stabilizes to 1.5 degrees Celsius by 2100. And the temperature increase is dependent on the total amount of carbon we have in the atmosphere, not the rate at which we're emitting the carbon. So to completely halt the rate of temperature increase, we need to stop adding carbon in the atmosphere or achieve something that's called the net zero emissions. Net zero just means for every gram of carbon we add to the atmosphere, we have to take it away. So the overall mass of the carbon remains fixed. The second principle is about electricity. How building applications that are energy efficient can help us reduce our energy consumption / electricity consumption. The third principle is about carbon intensity. The carbon intensity of electricity is a measure of how much carbon emissions are produced per kilowatt hour of electricity consumed. Not all electricity are produced the same way. Some are produced by burning of fossil fuels, and we consider those electricity dirty. And some others are produced by renewable sources, such as wind or solar, and we consider those clean. So if I plug my laptop directly into a wind farm, then the carbon intensity of electricity that my laptop consumes would have a carbon intensity of 0. But none of us can really plug anything directly into wind farms. Instead, we use power grids. Those power grids are normally supplied with electricity from a mix of sources. And because of the varying nature of renewable sources, the carbon intensity of electricity changes by location and changes over time. So if we can be flexible with when and where we consume electricity, we can then choose to run our workload when the carbon intensity is less. For example, I can choose to host a Bitcoin farm at a location that has 0 carbon intensity. Or if I have a batch job that needs to run once a day, why don't we look for a time frame that is the least carbon intense? The fourth principle is the embodied carbon. Embodied carbon is the amount of carbon pollution produced during the creation and disposal of a device. But why do we care? We're not hardware engineers. Almost everyone's first thought when the application is laggy is, I should probably get a new phone. The average lifespan of mobile phone is estimated at 2 years. It's not even just the mobile phone, it's the hardware in our laptops. As developers, we can make sure that the applications we build can run smoothly on older hardware. Here are all the 8 principles. I do encourage you to go check them out and familiarize yourself with them, because by understanding those 8 principles, we are in a great position to define, build, and run green software. Right, so if I can make a tiny guess on what you're thinking right now, are you thinking, wow, I did not realize software engineers can have a real impact when it comes to addressing climate crisis? Or are you also thinking, okay, what now? I know about the principles, they're all well and good, but what can I do and where can I start? Don't worry, I got you. I was feeling and thinking exactly the same time last year. I was inspired by this one sentence in a podcast. This podcast is not even about green IT. It was about cloud monitoring. The founder of this cloud monitoring made a career transition from security. And while he was discussing the transition with the host, he said something along the line that how he can now use his expertise to have a real impact tackling climate change. This one sentence really resonated with me. I've always tried to do better when it comes to being more environmental friendly. But there's just so much I can do by grieving my friends or family when I see them use plastic bottles. So now I want to share my journey with you, what I have done internally and externally, and hopefully those actions can inspire you to start your own journey as a green software engineer. So the first thing I did after the podcast was to hit the internet. I wanted to see what has been done in a space. We are all software engineers. We don't like reinventing the wheels. Then I found green software engineering as a discipline, which led me to climate action tech. Again, it's a very vibrant online community for any type of tech workers who are passionate about utilizing their technical skills to address the climate crisis. Since joining, I've started volunteering. Right now, I'm helping out new members to onboard and make sure they are settled in. And most importantly is to make sure that the new members are connected with others whom they share common goals or interests. I really love the community's energy and the variety of topics that it covers. And every time I have a question, it's always responded quickly and with very useful information. Even though my volunteering responsibility right now doesn't cover any actual technical work, but I do feel like I'm having an impact in the space. The community is also very open to new ideas, and right now we have kickstarted a new proposal, which I hope will massively help out others who are in the same boat as me. Where finding the right project with the right tech stack in the correct time zone is really tricky nowadays, with everything online with like 100 different open source projects you can get involved with. And last point I want to make is that green software engineering is not necessarily a new discipline, but a discipline that has gained a lot of traction lately due to the current climate crisis. So a lot of people aren't aware of this topic, not realizing how much an impact our daily activities as software engineers can have. So earlier this year, I put together a deck very similar to this one, and I started talking about this topic to basically any engineers who would spare me 2 minutes. What about what I did internally at my company? Very similar to what I have done externally. I started by giving talks to engineers in my region. Then I found a group of like-minded engineers, and now we have a working group on green software engineering. Again, what we realized, this discipline is not very well known. So we have a shared deck that we use whenever an opportunity should arise for us to raise awareness. The working group has now grown to a healthy size that we are capable of running multiple initiatives concurrently. So what about you? What can you do next? Before we jump into the resources for front-end and back-end engineers, I just want to reiterate that volunteering is a worthwhile contribution in this space, and I do encourage you to find a topic that you're most interested in. It's a shame that we're not in person, and I can't ask you to raise your hands and see how many of you are front-end engineers, because you guys are a very lucky bunch. The work that has been done in space is very impressive, and they're all readily available online. For example, if you're a designer, there's a book called Sustainable Web Design. The book describes an approach to designing digital products and services that puts the people and planet first. The author of this book is also the founder of a boutique WordPress firm in London, and they have made a head start in a green space. They regularly publish blog posts, for example, the one you see on the slide, 17 ways to make your website more energy efficient. They've also built a calculator that estimates the amount of carbon your website would have emitted per year. And here I've tested out the BBC News homepage, and turns out it's not a very green site. The amount of carbon emission estimated is roughly equal to what 14 trees would have absorbed in 1 year alone. And if you're a mobile developer, building a progressive web app is not just making your application more efficient and how you can reach more audience. All the benefits that come with building a PWA have a green aspect to them as well. And if you're a backend engineer, there are also loads of work being done in the space, not as much as the front end, but just enough to get you started. There's a very interesting study done back in 2018, where they benchmark tested different programming languages, and they've provided a useful table for you to consider which one to pick based on optimal sets. For example, C, Pascal, and Go are the top choice if your optimal objectives are time and memory. Microsoft is also leading the pack here, where they have started a blog post sharing tips and tricks on how to write green software. And this particular one I've shared demonstrates how you can measure power consumption of your backend services. And lastly, there's now this open source tool available if you host your solution with any of the following cloud providers: AWS, Azure, or GCP. This is a really, really nice tool that uses the out-of-the-box APIs provided by each cloud provider to estimate the carbon emission of your workload. But what about SRE and DevOps space? Right now, there's not a lot being done in the space. We are in a phase where applying green software engineering principles is going to start make waves across the tech world. And how would those affect the way we support, for example, a full night service? Is it possible for us to do monitoring based on demand instead of having a Prometheus cluster running 24/7? Right, before we start the Q&A, I want to quickly talk about the additional advantages for going green. We're not just building applications that emit less carbon, we're also building applications that are more resilient and performant. And when a piece of software is more resilient and performant, it normally costs less too. So I guess that brings us to our last slide. I hope you have enjoyed this talk, and the talk has inspired you to kickstart your GSE journey. Remember, it's Earth Day every day. The planet is in desperate need of help from anyone and everyone. Thanks, guys. Right, let me just go to the chat function. Can we get? Well, I will reach out to the organizer and see how I can share the slides. Yeah, I actually do have another slide, but I don't really want to make this session too preachy, but let me just quickly share that with you. So basically, there are some habits we do when we are tech users. For example, when you stop using your computers, you can try switch it off. We can then save energy and electricity. And if you're watching Netflix, if you have the opportunity to download and not stream, that can also save a lot of like electricity. And again, we're all software engineers. Dark mode is saving us so much energy. So change your IDE to dark mode. And Zoom meetings. I know like this has been a crazy year where Zoom has transformed the way that we have experienced Corona. If we're in a different, decade. And so if you are in a Zoom meeting with 100 other people, where sharing your face is really not that important, you can try turning it off. I think there was a study, basically, if you turn your camera off during a Zoom meeting, you can reduce about 87% of the carbon emitted if you have your camera on. Again, digital clutter, declutter. Try to delete things like you don't need anymore, because those are taking up space, those are taking out your RAMs and CPU when you're running your laptop. And lastly, prolong electronics. You can do like, I know I'm the same, I live in the UK. I always try to buy a new phone every 2 years. Don't know why, they still work, but just probably my contract run out. And then they try to sell me a new phone and I buy it. So it is a really difficult transition to make, but hopefully with the common goal to decarbonize globally, those are the habits we as tech users can also pick up. What's the difference between download and stream? Oh, I guess like streamings, because the way that Netflix where they have like CDN, right, at the different edge locations. So they will have to make sure that the CDN is working in the nearest location with where you are, right? But if you download it after they send it off, you don't have to keep going back to Netflix and have like a connectivity between your phone and Netflix, right? So you can basically watch TV without internet, and that's saving a lot of electricity and energy. Cool. I think does anyone else have any more questions? Yeah, I know the Mozilla Foundation has been doing a lot of really interesting work, and I'm really looking forward to what they have achieved. Yeah, and myself is an SRE, and I'm really interested in SRE and DevOps space. So hopefully there's something coming out of this space in the next couple of months. I have faith. And if you're really interested in partner up to do something with me, please do reach out to me. Could you hear me at the end? Oh, no, I can't hear you, Iona. How can a software engineer start applying green software engineering principles at work? Right, I think it really depends on the size of your organization and then who you need to convince, if that makes sense, right? And but then before you actually say, hey, we need to redesign all our architecture, we need to rewrite all our code. But before you get to there, why don't you think about, hey, I have a batch job that runs once a day, but this batch job lives on a machine that is running 24/7. Can we try to turn those machines off? Just by doing that, we are saving energy and then proxily carbon. So I think by applying green software engineering principle is very useful. But then again, it really depends on your organization size and who you can convince. And right now, because the discipline is so new, if you Google, hey, what's the most sustainable way for me to deploy a Spring Boot application to AWS, you can't find any like pattern or like blog post. So hopefully in a couple of months, then people will be able to use some of the out of the box too. And then you can then say, hey, I've seen this guy deploying a Spring Boot applications, applying green software engineering principles, and this is how much carbon, how much cost they have saved. Why don't we try to apply that at work?
Yeah, now maybe.
Yeah, I can hear you. Yeah. I can hear you.
Yeah. Important thing that I was trying to unmute is that main practice is that all the whole amount of carbon nice, because as you mentioned, we don't that consider, and you were mentioning it would be nice a video in Zoom calls that everyone started of the pandemic, the camera over to yes to think about all the bad practices just because other sides, but we don't, and that bring the light too are very important. So thank you for stepping in, share these practices in terms of the impact so that you already had, and it would be nice to share even if the audience has to learn more, familiar with the topic. I literally title of your presentation to see on your side, and we have a let's. What I find difficult than others are bad on areas. How other areas are in assessing the impact of risk.
Yeah, so there's a question. What I found difficult is, yes, AWS greener than others, but there are also bad on so many other areas, how other areas should be integrating and assessing greens and human impact of resources. Yeah, I agree. To be honest, right, AWS is actually one of the cloud providers right now does not have a transparent solution, transparent data point for their customer to see how much carbon my hosted solution is costing. Like GCP have something called a carbon-free energy, and Microsoft, they have a calculator for their enterprise customers. But then again, right, hopefully with like so many people now are interested in this topic and how all these topics are in the front page, we can then like reach out to Amazon or like change the way they help out their customers basically. Switching camera off is a trade-off for not commuting and avoiding travel, so definitely worth it to keep us all connected. I definitely agree. Zoom meeting is very important. So like, I think what I was trying to convey is that if you're in a massive meeting with like 100 other people, when showing your face or when you're not speaking, turning your camera off then is probably useful. But yeah, if it's like one-on-one meeting or like a meeting with less than 10 people, I think definitely have your camera on. Otherwise, it would be very sad not to see your teammates. Great, thank you so much, Jessie, for sharing links on SRE.
Question from Alpha, automation testing and deployment impact.
And that is a DevOps space that there's not a lot being done. So for example, right, I'm mainly working AWS. There are so many different ways of deploying infrastructure to AWS, but I don't know which friendly. I can use Terraform infrastructure as code. I can use CloudFormation. I can use CDK. I can use other different tools. But right now, there is just no data set against any of those considerations, right? So it would be really useful in the future if there is available, there's a tool available out of the box for any of those IAC. And then same thing for like automated testing, like how you have to set up every bit of your automated testing. For example, your front end, your back end, and then like running some like user testing and stuff. Thanks, guys.